Hey, this is Dr. B, and let's take a look at solutions. These are defined as homogeneous mixtures, and by and large, what we mean by that is that only one thing is visible, and yet there is a mixture present. You'll find them just about everywhere, particularly if you go grocery shopping. So they have two things present in them. The one is that present in the larger quantity is defined as the solvent. Most people refer to that as the dissolver. We also have a substance, perhaps more, that is a minor component, and one can refer to that as being dissolved by the solvent. If you have detergent, the solvent is very likely going to be water, and the detergents will be your solutes. Coca-Cola is predominantly water, although in some cases sugar might be a close second. Another solute for sure is that dissolved carbon dioxide. Olive oils and other oils are mixtures of oils, therefore somewhere in there is a major oil. The minor oils are the solute. Brass and other alloys have a predominant metal. In this case, copper would be the solvent. The other metals, such as zinc, would be the solute. Very likely one needs to melt these to get a homogeneous mixture and then let them freeze. Gatorade is mostly water, and some salts have been added. By the way, this would be a solution that happens to be an electrolyte. It conducts electricity by virtue of those salts. Listerine has a lot of water in it, and you might be surprised how much alcohol is also present. Air is mostly nitrogen mixed with other gases, predominantly oxygen. Is it a solution? Pure salt? No, because it's only one thing. Gasoline? I think so. You have a lot of different liquids that are soluble in each other. Granite, the fact that you can see that it's speckled means that this is a heterogeneous mixture, not a solution. A diamond looks nice and clean, but if it's pure, it's only one thing present, carbon, therefore not a solution. Coffee, I think so. You would have water and lots of dissolved materials in the coffee, so yes. Sheen, although, he's a good-looking guy, I can't qualify him as a solution. He is a heterogeneous mixture. For a solution, things have to dissolve in each other. And let's take a molecular view of dissolving. If you have sodium chloride, it is a salt. It is not yet dissolved. If we add some water, those water molecules will form some favorable intermolecular attractions. Notice the hydrogen's the electropositive part, that's white. The oxygen is the electronegative part. It will be attracted to the cations, and it's beginning to surround the solute, ripping it apart. Eventually, you will have the point where it's fully solvated, fully dissolved, and the solvent is surrounding the solute. This particular situation is the formation of an electrolyte, a salt solution. Other things dissolve as well besides salts. These examples should provide ample evidence of that. And let's consider some alcohols. This is a nice way of trying to theorize what makes something dissolve. Methanol is highly soluble in water. Absolutely. Ethanol is soluble, but sometimes people say they see legs or greasy components to it when it mixes. Propanol is getting even greasier by virtue of this growing hydrocarbon chain. Notice that the OH functionality looks a lot like water and probably can form favorable intermolecular forces with water, notably hydrogen bonds. But once you get to the point where it's butanol, it is sufficiently greasy that it overwhelms things and it is no longer soluble in water. You'll get this kind of a situation where both layers are clear and it becomes insoluble. From this, we can make the simple conclusion that for solubility, like dissolves like.